So in this video, we're going to talk about NO2+. This is called a nitronium ion, and we're going to ask ourselves, is this molecule polar or is it non-polar? And to determine this, we'll first have to draw the Lewis structure, right? Also, this is the best way of determining these polarity. So we know that we have a nitrogen, and we know that we have 2 oxygen. Now, from the periodic table, we know that nitrogen gives us 5 valence electrons, and oxygen gives us 6 valence electrons. So I'm doing this to count the total number of electrons I have to place, so that way I do not get my Lewis structure incorrect, right? So I know I have 2 oxygen atoms, so I must multiply 2 times 6 to get the total number of electrons. So that would be 12 plus 5, and that would be 17. So we have 17 total electrons because we have 12. 2 times 6 is 12 plus 5 from the nitrogen gives us 17. However, we do have a positive charge because this is an ion. Anytime we see a positive charge, if it's +1 in this case, then we must subtract an electron, right? If it was negative, then we would add an electron. So therefore, the real total number of electrons we have is 16, a total number of electrons that we have to place. All right, so again, usually the central atom will be the atom furthest to the left in the molecular formula. Obviously, it's not always the case. For example, H2O, oxygen is the central atom, but most of the time, this rule typically follows that the atom that's furthest to the left in the molecular formula will be your central atom, at least for these simple Lewis structure. All right, so at this point, I could put my 2 oxygen atoms around my nitrogen. And then I'm going to start off with single bonds. So I'm going to form a single bond between both my oxygen and the essential nitrogen. All right, so at this point, we have 4 valence electrons out of the 8. Out of the 16 that we have to place. Now, nitrogen is one of those atoms that typically satisfy the octet rule. So I'm going to try something. I'm going to place a double bond between both of these. Now, at this point, the nitrogen's octet is satisfied with 2, 4, 6, 8 around electrons around the nitrogen, so that is good. For the oxygen, since the nitrogen's octet is satisfied, let's move on to the oxygen. So we cannot place any more electrons on the nitrogen. So let's place 2 pairs of lone pairs on the oxygens. And let's see what happens. At this point, how many total electrons we have? 2, 4, 6, 8. So we have 8 electrons around this oxygen on the right. Now, how many total electrons we've placed in the molecular formula thus far? We have 2, 4, 6, 8, 10, 12. So we have 12 electrons. So therefore, we're missing 4 more electrons, and they certainly would go on the left oxygen. So both the octet is satisfied. Now, if you notice, there is a plus charge in the molecular formula. And we should know this by now, that the plus charge is essentially, will be on the nitrogen. The plus charge will be on the nitrogen, but when we draw our Lewis structure, if we're drawing ions, we put in parentheses or brackets in this case, and the plus charge. The plus charge in this case will be on the nitrogen because remember, if we do a quick formal charge rule, nitrogen has 5 valence electrons, and it really has 4 valence electrons total around the nitrogen atom, so that will give us a +1. Right, so this is just a quick, don't get confused about this. I just took a shortcut to show you that the plus charge is actually on the nitrogen. Now, with this, we need to draw our dipole moments. So we should know by now that nitrogen is in group 5. Oh well, nitrogen has 5 valence electrons. Oxygen is just to the right of that column, so oxygen is more electronegative than the nitrogen, right? So in this case, if we draw our dipole moments, we should know that oxygen is slightly more electronegative than nitrogen, and so nitrogen in this case will gain a partial positive charge. The oxygen will gain a partial negative charge because it is more electronegative. At this moment, we should see by now the picture that this molecule is linear, and so we do have dipole moments going tail to tail in the opposite direction, and so therefore, therefore, the nitronium ion is actually a nonpolar molecule.